Good morning, class. Today is Monday, April 27th, and today we're going to start a brand new unit, and we're going to start on the energy and conservation unit. And it's pretty ironic that we're starting this right around Earth Day, which is a great time to start. So the first thing I want you to do is I'd like for you to make sure that in Notability you have already created a new subject, and I want you to call it energy. So if you haven't done it already, please put this on pause and go ahead and make sure that you put add a new subject under the science divider in Notability and call it energy. All right, stop and pause it if you haven't already done so. So all the notes that we are going to be taking from now until the end of the year are going to go into this energy subject within our science divider, because this is the last unit of study for 7th grade, and it's pretty much going to take up the remaining 2 months of school. All right, so let's get back to where do we come from? All right, and we talked about forces for 2 months, 2 months now, and we said that forces are pushes or pulls. All right, well, just remember now that a push or a pull just doesn't come out of anywhere, right? In order to be able to push or in order to be able to pull, you need energy. Right? You can't do anything without energy. And so that's where this next unit is going to come from. All right, it's going to come. We talked about forces, and now we're going to say, well, here you go. In order to do these forces, we need energy. All right, and so that's the first sentence. It says, in order to do forces, we need energy. All right, think about when you're really, really, really tired. You haven't eaten all day. You're exhausted. Maybe you didn't have enough sleep. When you're tired, it's hard to do things. It's hard to keep your head up. It's hard to keep your eyes open. And that's because you're lacking energy. And without energy, living and non-living things don't work. All right? It's not only you can't really work without energy. I mean, maybe very minimally, but think about your computer or your iPad. If it doesn't have any energy or an energy source, it's not going to work. Here's 2 examples. You play a huge soccer game, all right? You're running your butt off. You're scoring lots of goals. It's 40 minutes long or 60 minutes long, however long a soccer game is these days. And you've used up, at the end of the game, you used up a lot of your body's energy. Therefore, you feel tired. You feel wiped out. How are you going to get that energy back? Well, you need food. The food will restore your energy that you used up. And if your body completely runs out of energy, if let's just say for the fun of it, that during that soccer game that your body completely runs out of energy and has no more energy left, in a sense, you will die. All right, now that doesn't happen, obviously, because normally you have some extra energy in your body. But if and when your body runs out of energy, that is the day that you will die. And that will happen to all of us. All right, example number 2, we're talking about non-living thing here. Your iPad runs out of battery. You've been playing, you've been playing your games all night long, late into the night, all right, and it runs out of energy. What happens? It shuts off. What must you do? You must plug it in and you must charge it to restore the energy. And a lot of times you're going to see signs like this. Well, that means it's out of energy. All right? It's out of batteries. Well, that happens to people too. People run out of energy all the time. Now, there are 8 types of energies. All right. Now, you have to remember that energy can be used by objects, living and non-living things, and it can also be used, and it can also be exerted or released by objects as well. So you can use energy. Your body can use energy. Your objects can use energy in order to do work, and then they also can release energy as well. And I want you to remember that. That's very important. We can use it and we can release it. And this energy is either used or released in 8 different ways or 8 different methods. Okay, so the first one, the first type of energy that we're going to talk about is potential energy. All right, and that's energy that is stored. It's not being used yet. I like to use the example in class. Let's say that, I know that Chase Masso, you're a good soccer player, but let's just say for this class that I came up to you and I said, Chase, you have so much potential energy. You have the potential to be a professional union soccer player. It's in your body. It's stored there. It's ready to come out. But you know what? You're just not using it yet. And when you do use it, when you use that potential that you have, you will become that star soccer player. Well, that same thing goes for all objects. All right? All objects have energy stored inside of them, whether it be by position or just by a gross amount of it. But there's always energy everywhere, and a lot of it is stored. And so therefore, we call this energy potential. I want you to think about a car on the top of a mountain right here. On the top of a mountain, it has the potential to go down. When it's at the very, 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 very top, it's not using that energy yet. It's just stored in the car. It's stored in its position because it's on the top of a mountain. It has the potential, just not using it yet. Think about a girl on a swing. All right? When she is at the very top, she has the potential to go down. She's not using that yet. That's the most amount of potential energy. She also has potential energy in the bottom as well, but the most amount of potential is on the top because she has the potential to fall downward. All right? And that brings us to our next one. And the next one is kinetic energy. And I'll do this one in blue. Kinetic energy. Now, the kinetic energy is energy released through movement, motion, and momentum. Now, we've talked about this a million times now in the last couple of weeks when we were talking about Newton's 3 laws of motion. Anything that moves, anything that's in motion, anything with momentum, it could be anything, is releasing kinetic energy. This girl on the swing, as she's swinging back and forth, has kinetic energy. Right? If you're playing soccer, you have kinetic energy. You're moving. If you're riding your bike, you have kinetic energy because you're moving. Once you stop, that kinetic energy goes away. All right? So now let's talk about thermal. Thermal's an easy one. I'm sure you could understand this one without me even talking about it. Plus, it's a picture of it right here. Thermal energy is energy released through heat. The key word is heat. All right? If something is hot, it is releasing thermal energy. You cook a pot of boiling water, you see the steam coming up, it's a release of thermal energy. You touch a fire, you touch a lit match, it's all releasing thermal energy because the energy is released through the form of heat. All right, radiant is next. I kind of lump these two together, all right, because radiant is energy released through light. All right, it's kind of like thermal energy. Radiant is light energy. Take a look at these examples. This candle right here is releasing light energy. It's also releasing thermal energy as well, but it's releasing light energy. A light bulb is releasing light energy, radiant energy. It's also releasing heat energy as well, but it's releasing radiant energy. A lightning bolt or the sun, they're all releasing radiant energy, energy released through light. Now, I will say, by talking about this, I lump these together because a lot of times when an object releases one, they also release the other. You can release as many, all 8 of these at one time. All right, but I lump them together because usually where there's light, there's heat, and where there's heat, there's light. All right, the next one is going to be electrical energy. All right, and the electrical energy is energy released through moving electrons. All right, now I don't know if you guys even know what electrons are. We really didn't get to touch this when we talked about electrical force in the last chapter unit because we ran out of time. But I want you to just imagine there's an outlet here. Okay, you guys know what an electrical outlet looks like. All right, you plug stuff in. Well, inside of that outlet, there's millions and millions and millions and bazillions and gajillions of little tiny particles called electrons. Now, these electrons, when they're moving around, create electricity. And they're being stored inside of that outlet. They're just sitting there, just waiting to come out. They're dying to come out. They want to just burst out of there and party. Okay? So when you take a plug, and you plug it into that outlet, those electrons, they start moving. They're like, all right, we're getting out of jail. All right, and they go through the little plugs all the way down the line, and they move into whatever device you are charging or you're using. And those moving electrons create an electrical current. Well, guess what this is? Guess what those little tiny thunderbolt or lightning bolts are? They are moving electrons. That's the little tiny dots of electrons going from one end to the other. They're moving through the wire. And therefore, if there are moving electrons, you get electrical energy. And once again, electrical energy can be either used or released. Remember that. That's very important. Sound energy. Love sound energy because it reminds me of a very funny movie that I watched called Dumb and Dumber. All right, Dumb and Dumber. Jim Carrey. I used to watch it all the time when I was younger. It's hysterical, and there's this one scene in it, and I'm gonna put the YouTube clip on this so you can watch it. It's freaking hysterical. All right, and it's sound energy is released through noise. Okay, it could be any noise. It could be me talking. It could be you talking. It could be yelling, screaming. But watch Dumb and Dumber, and you'll totally get what sound energy is, because it's like a 30-second clip that's going to make you laugh. It made me roll when I watched it for the first time, and each time I think about sound energy, I think of Dumb and Dumber and the amount of noise. So watch that, and you'll get it. All right, chemical energy is a little different. We'll do this one in green. Chemical energy is when two things, oops, I forgot a letter here, mix. All right, and that's really the key word. When you're putting two things together, two items together, and something new is made. Now, if something new is made, that means that a chemical bond has to be either broken or created. All right, now, so that just means like you can't just put, red sand and blue sand together. No, that's not chemical bond isn't broken. A chemical bond isn't created. You have to mix two things and something completely new is made. All right, I want you to think about those movies that you used to watch when you were a kid, and you have a mad scientist with two beakers, okay? And he's got, or two test tubes. And inside one of the test tubes, he's got like a green solution or a green chemical. And inside the other one, he has like an orange. So, and then they're bubbling up. They're bubbling. They're bubbling. They're bubbling and they're smoking. All right. And then he says to whoever it is, he says, when I put these two together, I will rule the world. And then, of course, you know what happens when he puts them together. All right, he puts the two together and he mixes them, and then all of a sudden you get a huge boom. You get a huge explosion. And why? Because energy was released. Chemical energy was released when he mixed the two. Something new was created. A spark, a bubble, a new product, an explosion. Something new was created. It's not a mixture. It's not a mixture where just two things are mixed, but something new, completely new was created. All right, so two things mix and something new is created because a chemical bond is either broken or created. All right, and last but not least, and we're not going to really talk about this one or work with this one as much in class, this is nuclear energy. And nuclear energy, the reason why we're not going to use this and have examples of this in class is because nuclear energy is radioactive and poisonous to us. It could kill us. So obviously we're not going to be using it in class, but it's released through the breaking of uranium. And it's not really just through uranium, it's also another item called plutonium. So there's this stuff called uranium and other stuff called plutonium. Sorry if I'm spelling that wrong. And these guys are radioactive elements. You dig them up in the ground. They're found all over the earth underneath the ground. And you dig them up, and they're radioactive and poisonous, and they're very, very dangerous. All right, Homer Simpson works at a nuclear power plant, and that's what he's holding a piece of uranium. Now, obviously, you wouldn't be able to hold a piece of uranium because it would burn your hand off. But if you were able to get a hold or a piece of this uranium or plutonium stuff, which you wouldn't be able to because it's illegal, and you take this uranium or this plutonium, and you take the atoms that are inside of it, and you find a way to break those, and to break this piece of uranium or to break this piece of plutonium in an atomic way, it will create a huge explosion full of nuclear energy. Okay, so this is very dangerous. This is what nuclear bombs are made out of, and this is nuclear energy. It's energy released through the breaking of uranium or plutonium. All right, now these are the 8 types of energies, and remember that you need energy in order to do any kind of force, any kind of push, or any kind of pull, and these energies can either be used by an item or a person, or released by an item or a person. All right, take these notes, use them, and work on the assessment that I gave you as a worksheet. I hope you guys understand. If there's any questions, I will be available all day. Thanks a lot, and good luck.